Hello and good morning po sa lahat. Good morning to everyone. This is Chemistry Rules, and today what we're going to do is we're going to discuss the tetrahedral bond angle. So you may have heard that. So the tetrahedral bond angle, it's 109.5 degrees. So 109.5 degrees. So this is tetrahedral tetrahedral bond angle. Okay. Now, where do we get this 109.5 degrees? Obviously, it's not just a random number picked by a random person, right? So today, we're going to prove it. We're going to prove that the tetrahedral bond angle is 109.5 degrees. So first, we have to visualize a tetrahedral bond molecular geometry, okay? So first, we get a molecule with 4 bonds. So like methane, 4 bonds, and the 4 atoms attached to the central atom are equal in mass or in pull, okay? So let's just say we have methane. So this is the central atom, and then these are, let me write, CH, H, H, and H. So now, we're going to visualize methane inside a cube, okay? So this is a cube. So we have to remember that in a cube is a three-dimensional square, okay? So it means that all faces are composed of the same square. So this space here is the same square as this space here. It means that the measures are all the same. It means that this side here is equal to this side here is equal to this side is equal to all of the sides in the cube, okay? So now that we have that, we set a side here as length x, okay? Let's say that this side here is length x. It means that this side here is also length x. This is also length x. Length x, length x, everything is length x, okay? Now we're solving for the angle between these two atoms, okay? Let's just take two atoms, okay? So the bond angle, so it means that the bond angle here is supposed to be 109.5. The bond angle here is supposed to be 109.5, and so as here and here, okay? Let's just take this. So now, as you can see, this central atom here is in the center of the cube. It means that from this atom here to the bottom of the cube, that is x divided by 2. And from this atom here to the top of the cube, it's also x divided by 2. Okay? Now that we know that, let us redraw our triangle here. Okay? Let's just say that this is the central atom. And then this is the H. This is the H. Okay? Let's just say that. Okay. Wait, let me straighten my lines. I'm very sorry for that. Okay, there you go. Okay, now that we straighten the lines, okay, so it means that from here to the bottom, that is equal to x over 2. Alright, this is x over 2. Now, as you can see in the first figure, so the atom is in the back side of the cube, and this atom here is in the front side of the cube, and is in the left side, and the one in the back side is in the right side of the cube. Okay. Now, what connects these two atoms? Okay, so what connects these two atoms is the diagonal of this face, okay? So let me draw this here. So it's this one. So this connects it. This connects the two atoms. So let's do it. Let's draw that two-dimensionally here. So okay. So this is this. Okay. It's the same. It's the same line segment. Okay. Now what is the measure of this? Okay. Now to get that, we have to review some theorems from our trigonometry classes or geometry classes, okay? So what we're going to use here is the Pythagorean theorem. So remember that in a cube, all the vertices, what do we call this a vertex? All the sides are equal, okay? It means that this is x and this is also x. So as you can see, this is a right triangle. Okay, it means that this here is equal to 90 degrees. And now if this is equal to 90 degrees, we know that in the Pythagorean theorem, c squared is equal to a squared plus b squared. Or basically the hypotenuse of a right triangle, the square of the hypotenuse of the right triangle is equal to the sum of the squares of the legs of the right triangle. It means that if we're going to apply the Pythagorean theorem to our given here, we would get the hypotenuse, which is the diagonal, is equal to x squared plus x squared. Okay? And we simplify that, that becomes d squared is equal to 2x squared. Okay? And then that simplifies to d is equal to 2, the square root of 2x squared. And we take x squared out of its square root, we get the length of the diagonal is equal to x square root of 2. Alright? So we know that this is x square root of 2. Okay? This is x square root of 2 from here. And then, we also know that this angle here, that is angle theta, that is equal to the tetrahedral bound angle. Okay? Let me write. So that is the tetrahedral bond angle. This is equal to the tetrahedral bond angle. Now, how are we going to compute for that? We're given here. So we can divide this whole triangle here into two right triangles, okay? Now we have this right triangle here. Well, let's divide this. Let's just remove this. This is theta over 2. Okay? Theta over 2 is equal to what? So remember, in right triangle, we have the functions. We have the sine, cosine, and tangent functions. The SOHCAHTOA, okay? Now, if we need to find this angle, what do we have? We have its opposite, we have its adjacent. We don't need to find the length of the hypotenuse, okay? We can just use theta over 2 is equal to inverse tan. Opposite, what is the opposite? So remember that x squared root of 2 is equal to this whole segment here. So this segment alone is equal to x squared root of 2. X squared root of 2 over 2, okay? This segment here is equal to x squared root of 2 over 2. So the opposite is x squared root of 2 over 2 over x over 2, okay? X over 2. So that simplifies to this gets cancelled, this gets cancelled. So theta over 2 is equal to the inverse tan square root of 2. So what is inverse tan square root of 2? So inverse tan square root of 2 is equal to 54.73. 7356. Okay, let's not take the next decimal places, okay? That is enough. Okay, we have 54.7356. Remember that we have computed for theta over 2, which is half the tetrahedral bond angle. Now, let's multiply this by 2. We get what? That is 2, that is 1. Then this is 1, this is 1, 7, 1, 5. This is 1, 9, this is 109. Wait. Oh, okay. Apologies for that. So we get 109.4712, which then rounds off to 109.5 degrees. Okay? So that's how you compute for the tetrahedral bond angle. 109.5 degrees. Okay guys, thank you for watching this video. I am apologizing for the lack of organization in my video. I'm just starting, and I'm not an experienced video creator. So thank you for watching. Please subscribe for more videos, and I'm looking forward to create more videos containing chemistry related topics. Thank you. Goodbye.